And moving right along to one last example, or maybe two, I'm not sure. So if we're going to consider a function f such that x is converted into 3x squared minus 2, we want to determine f inverse using variable interchange. And then we're going to state whether f inverse is a function and explain why. So f of x is equal to 3x squared minus 2. That means that y equals 3x squared minus 2. We interchange x and y. That's the variable interchange. So 3y squared minus 2. And now we'll just solve for y. So we add 2 to both sides. Then we'll divide both sides by 3. Which gives us y squared. And then we'll take the square root of both sides. So we get x plus 2 over 3. Take the square root of that and put in the plus minus. I'm kind of cheating a little bit. Should have been plus or minus on the right side, but eventually it comes over to the left. So f inverse of x equals plus or minus x plus 2, or the square root of x plus 2 over 3. So by using our transformations, we know that this is the square root of 1/3 of x plus 2. Which means that there has been a horizontal translation, as I'm trying to get this 3 to write properly, horizontal translation to the left 2. There has been a horizontal stretch by 3, and we're taking the square, and that's the square root function. We see that also, if we were to use I'll just draw a quick sketch here. The regular square root function looks like that. If we have a plus or minus, it looks like this. And the fact that it's been stretched horizontally by 3 doesn't really matter, and the horizontal translation doesn't really matter either. The one thing that does matter is the fact that we have some vertical lines that we can draw here. Whoops, sorry, vertical lines. And all of them but except one, and this is not the function here. This is just a square root function, but the fact that it's been stretched horizontally and translated horizontally doesn't make a difference. The vertical lines still touch the function twice, which means that this is not a function. So that is not a function. As it fails or does not satisfy the vertical line test. I really wish I could write neater. Maybe I'm rushing. Okay, great. So that is that. Okay, so we have one more example to work through here. So we're going to consider the functions f such that x is converted into 3x squared minus 2, and g such that x is converted into root x. So, and what we're going to do is solve the equation g inverse composite f of x equals 25. So first of all, we know we need the g inverse. So I know that g, this form of the x, g such that x is converted into root x, is the same as g of x equals root x, which is the same as y equals root x. And then we do the variable interchange. So I'm going to interchange x and y. And now I'm going to solve for y. So I'll square both sides. So you get x squared equals y. Therefore, g inverse of x equals x squared. Okay, so that's part of what we need to do here. So g inverse, I'll look at the left side first. So g inverse composite f of x, that's the same as g inverse of f of x. And so I know g inverse is x squared. F of x is 3x squared minus 2. So I'm going to substitute 3x squared minus 2 in for f of x. And now I will substitute that 3x squared minus 2 in for x of the g inverse of x. So that becomes 3x squared minus 2 all squared. Now we need, so this is g inverse composite f of x right here, 3x squared minus 2 all squared. And we want to solve this when that equals 25. So I'll say 3x squared minus 2 all squared equals 25. And I have to start solving this. I'm going to have to take the square root of both sides. So I'm going to get 3x squared minus 2. And because there's a variable here, we need a plus minus root 25. Now technically the plus minus should have been over on this side, but then eventually it comes over to the right side anyway, so I'll just skip a step and bring it over to the right side. So then that becomes 3x squared minus 2 equals positive or negative 5. So we have a couple things that we have to do here, or a couple options, I suppose. So first we do 3x squared minus 2 equals positive 5. And then we'll look at 3x squared minus 2 equals negative 5. So I'll add 2 to both sides here. So we get 3x squared equals 7. Divide both sides by 3. So x squared equals 7 divided by 3. And then I'll take the square root of both sides. So again, with the plus minus, the square root of x squared is x, well, plus or minus x. And then that plus or minus will come over here eventually, so I'll just do that right now. And that equals this plus or minus the square root of 7 over 3. So when the composite of, the composite of inverse of g and f equals 25 when x equals positive or negative the square root of 7/3. So now for this other option, when x is negative 5, or sorry, when 5 is negative, we add 2 to both sides, so we get 3x squared equals negative 3. Divide both sides by 3, so we get x squared equals negative 1. And if we take the square root of both sides, we here on the right hand side we would get the square root of negative 1, which is undefined. So therefore, in this case, this leads us to an undefined result. Therefore, the composite of inverse of g and f equals 25 when x equals positive or negative root 7/3. So there is your work for today. Hopefully you've enjoyed this lesson. Maybe do a couple of these in the evening now, and then come to school tomorrow and finish off the rest in class. So thanks for watching, and we'll see you in class.